Welcome back. Standard 9 Science Atoms and Molecules. Very easy lesson and very interesting. So let us start. Ancient Indian and Greek philosophers have always wondered about the unknown and unseen form of matter. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination: laws of chemical combination and laws of conversion of mass. This says that law of conservation of mass states that mass can neither be created nor destroyed in chemical reaction. Law of constant proportion. In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1 is to 8. The ratio remains the same, whatever the source of water. This law was stated by Proust as in a chemical substance, the elements are always present in definite proportion by mass. So, the smallest particle of the matter are atoms. According to Dalton's atomic theory, all matter, whether an element, compound, or mixture, is composed of small particles called atom. All matter is made up of tiny particles called atoms which participate in chemical reactions. Very important points. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atoms are constant in a given compound. Please read the points again, very important. Now we will see what is an atom. The building blocks of all matter are atoms. The building blocks of all matter are atoms. Atoms are very small. They are smaller than anything we can imagine or compare with. Then we come to what are the modern day symbols of atoms of different elements. Dalton was the first scientist to use the symbols for elements in a very specific sense. You can see figure 3.3: hydrogen, phosphorus, copper, gold, carbon, sulfur, lead, platina, oxygen, iron, silver, mercury. These were the some symbols of some elements proposed by Dalton. IUPAC is an international scientific organization which approves names of elements, symbols, and units. Hydrogen H, aluminum Al, cobalt CO, and not CO. See the symbols, huh? Symbols of some elements are formed from the first letter of the name and a letter appearing later in the name. Example are chlorine, zinc. For example, Fe is derived from ferrum, sodium from natrium, potassium from kalium. Very important, learn by heart. Aluminium Al, argon Ar, barium Ba, boron B, bromine Br, calcium Ca, carbon C, chlorine Cl, cobalt Co, copper Cu, fluorine F, gold Au, hydrogen H, iodine I, iron Fe, lead Pb, magnesium Mg, neon Ne, nitrogen N, oxygen O, potassium K, silicon Si, silver Ag, sodium Na, sulfur S, uranium U, and zinc is Zn. Okay. Now we go to the next point is atomic mass, matlab weight of an element. The most remarkable concept that Dalton's atomic theory proposed was that the atomic mass. According to him, each element has a characteristic atomic mass. The theory could explain the laws of constant proportion so well that scientists were prompted to measure the atomic mass of an atom. So let us see now what do you mean by atomic mass. Now the atomic mass is shown in this Table 3.2, hydrogen 1, carbon 12, nitrogen 14, oxygen 16, 23, 24, 32, 35.5, and calcium is 40. Atoms of most elements are not able to exist independently, so they form molecules and ions. Now, what is a molecule? A molecule can be defined as the smallest particle of an element of a compound that is capable of an independent existence and shows all the properties of that substance. Atoms of the same element or of different elements can join together to form molecules. Molecules of an element are constituted by the same type of atoms. For example, a molecule of oxygen consists of two atoms of oxygen. So we write O2. Diatomic O3. Ozone, diatomic molecule O2. Three atoms, then it is ozone. The number of atoms constituting molecule is known as atomicity. Okay. So once again, two atoms, diatomic O2, three atoms, so it is O3. Now you can see non-metal, monoatomic, diatomic molecules of compounds. Atoms of different elements join together to form a definite proportion to form molecules of compounds. For example, water. Water is a combination of hydrogen and oxygen. Ammonia, nitrogen and hydrogen. Carbon dioxide, carbon and oxygen. What is an ion? Compounds composed of metals and nonmetals contain charged species. The charged species are known as ion. Ions may consist of a single charge atom or a group of atoms that have a net charge on them. So ion can be positive or negative. For example, NaCl. NaCl we write no charge is mentioned on NaCl, though Na has got plus charge, Cl has got minus charge. It nullifies, so gets NaCl. NaCl, sodium chloride, common salt. How to write the chemical formula? You can see in this table very nicely it is given. Sodium, let us see the valency. +1, potassium +1, positive, silver Ag +1, iron +1. You can see the table. The combining power or capacity of an element is known as its valency. Valency can be used to find out how atoms of an element will combine with the atoms of another element to form a chemical compound. Valency of an atom of an element can be thought of as hands or arms of that atom. Now we are going to the next point, that is the formulae of simple compounds. Formulae of hydrogen chloride HCl. Both way the valency is +1 -1, so we write HCl. Formula of hydrogen sulfide. Sulfur is -2, hydrogen is +1, so we write H2S to balance the charges. Now we can see carbon tetrachloride CCl4, magnesium chloride MgCl2, Al2O3 aluminum oxide. So the positive and the negative charges must balance each other and the overall structure must be neutral. Is it clear? You can see the various examples given. Molecular mass. The molecular mass of a substance is the sum of the atomic masses of the atom in a molecule of the substance. It is therefore relative mass of a molecule expressed in atomic mass unit. Calculate the relative molecular mass of water. Atomic mass of hydrogen is 1 U, oxygen is 16 U. So the molecular mass of water will be H2O. So 2 into 1 plus 1 into 16 gives you 18 U. HNO3. Hydrogen 1, nitrogen 14, oxygen. 16 into 3 is 48, so it becomes 63U. Formula unit mass of a substance is a sum of the atomic masses of all atoms in a formula unit of a compound. Formula unit mass is calculated in the same manner as we calculate the molecular mass. The only difference is that we use the word formula unit for substances. So let us see, sodium chloride, NaCl, sodium 1 into 23, chlorine is 35.5, so we get 58.5U. CaCl2, Ca is single, Cl2 is 2 times, so we write 40 plus 2 into 35.5, we get 11U. So these are the points what we have learned. This is your exercise, so please try to find out the answers. Everything is there in the textbook. Thank you.